Hi friends, let's learn about linear recursion. The other names given to linear recursion are preemptive recursion, single recursion, direct recursion and non-tail recursion. Recursion is a function calling itself or in computer programming recursion is a process that calls itself as a subroutine. If you want a detailed video on recursion and its types of recursion, advantages, disadvantages and the syntax of recursion, please do see my other video on recursion, which I have given the URL in the description box. Please watch that video if you want to know about recursion. So linear recursion is a type of recursion where the function makes a single call to itself. Tail recursion is a type of linear recursion, and I have also made a video on tail recursion. If you want to know about it, please see the video. So what does it mean by linear and non-tail recursion? Linear recursion is also sometimes called as non-tail recursion. By the end of this explanation, you'll clearly understand what does it mean by non-tail recursion. So I have taken an example of factorial. This is a C program written for finding out the factorial of a given number. The first statement is a header file. The second statement is function prototype. So I am taking a function which is named as factorial and it is written in an integer type and it is taking int as an argument. And so in the main function, you are asking the user to enter a positive number. You are reading the number n, and once you are reading the value of n, you are calling the function. So as soon as the function is called, the control goes to the called function. Now inside the called function, you have a base case and a general case. The base case is that if n is equal to 1, we are returning 1. As I have already explained to you in introduction to recursion, that base case always drives you towards the known answer, and that's also called as an exit case. Okay, so here you know the answer for 1 factorial, which is 1. So your base case is driving you towards the known answer. So else, if n is not equal to 1, then you are asking it to compute n into factorial n minus 1. So we'll see how recursion works, how linear recursion works. Now say n is equal to 5. Recursion implicitly calls a stack, and since I said that it is non-tail recursion, there will be computation still pending after the last recursive call. We'll see how it works. Now say n is equal to 5. So n is not equal to 1. So it goes into the else part. Inside the else part, we are asking it to compute n into factorial n minus 1. So you want to first compute the 4 factorial. So once you compute 4 factorial, you can substitute the answer for the larger problem. So you are asking it to do that. So since you cannot compute n into 4 factorial as of now, because you don't know the answer for 4 factorial, recursion stores the answer in a stack. So 5 into, so it wants to compute 4 factorial. So it will store 5 in a stack. Okay, so here there is a stack and top is pointing to 5 now. So after that, the next recursive call is made, and the next recursive call is made for n is equal to 4. So again n is not equal to 1. So it goes into the else part, and now you want to compute 4 into 3 factorial. So you are again dividing the problem into smaller chunk. Now you can't calculate the factorial of 4 unless and until you know the answer for 3 factorial. So your recursion is storing the answer, the first operand 4 on a stack. So now this is the status of the stack, and the call is made for n is equal to 3 now. So 3 is not equal to 1, so it goes into the else part. Okay, so now you want to compute 3 factorial. To compute 3 factorial, you need to know 2 factorial. So you don't know one of the operands. Okay, so you know only one operand. The other operand need to be computed further. So you are storing the one of the operand on the stack. So 3 is pushed into the stack now. Okay, so it's storing these particular operands for further computation. Next, now recursive call is made for n is equal to 2. So 2 into factorial 1. you want to know the answer for 1 factorial to find the factorial of 2. Now this is when your base case is encountered, because you know 1 factorial is 1. So now you know the answer for 1 factorial. So now your recursion has stopped. But even if the last recursive call has been made, there are still pending operations to be done. If there are pending operations still after the last recursive call, such type of recursion is called as a non-tailed recursion. So now the computation takes place. After base case is encountered, the computation takes place. So now you can see that the computation is taking place. So now you are finding out the factorial for 2. So 2 into 1 is 2. The answer is pushed into the stack. Now taking the 2 factorial, now you have to find the factorial of 3. Okay, so now 2 into 3, which is giving 6. Now the factorial of 3 is 6. The answer is pushed onto the stack. Now you need to compute the factorial of 4. 4 factorial is computed as 4 into 3 factorial. The answer for 3 factorial is 6. You got 6 from the previous computation. So 4 into 6 is equal to 24. 24 is pushed onto the stack. Now you know what is the answer for 4 factorial. So the answer for 4 factorial is 24. Now we are substituting it for 5 into 4 factorial. So 5 into 24 will give you 120. So the answer is 120, and 120 is pushed onto the stack, and nothing is there here to further compute. So 120 is the answer. So this factorial function will return 120 to the called function, and 120 is stored in fact, and you are just printing that 5 factorial is 120 on the screen. So hope you understood linear recursion, friends. Thank you for spending your time for me. Please like, share, comment and subscribe. Thank you. Bye.